the new 3.4-liter V6 twin dual-cam engine from General Motors. Without question, a high-tech power plant of world-class design. With a design heritage born and bred on the racetracks of the world, the General Motors 3.4-liter V6 twin dual-cam engine uses the latest in automotive technology while remaining true to the General Motors engineering tradition of performance with durability and reliability. While using the latest in automotive engineering technology, you'll find the 3.4-liter V6 twin dual-cam engine is easy to understand and service is straightforward to perform. As the name indicates, there are dual overhead camshafts on each cylinder head. Why two overhead cams? This engineering innovation allows for higher output and better fuel combustion than other conventional engines through the use of 4 valves per cylinder. Overhead camshafts also cut down on the number of moving parts, and that reduces friction and the loss of power through reciprocating mass. Overhead cams optimize valve train stiffness to allow for maximum valve train speeds. More powerful, more efficient, more durable, all directed at higher customer satisfaction. The new General Motors 3.4-liter V6 twin dual-cam engine boasts a horsepower rating of 210 horsepower with a torque rating of 215 foot-pounds and a compression ratio of 9.5 to 1. The 3.4-liter V6 twin dual-cam engine has a power-to-weight ratio of 18 to 1, impressive for a power plant of this size, and higher than many engines of larger displacement. The engine block itself should be familiar. It is similar to the one used in the 3.1-liter General Motors engine, but the similarity ends there. General Motors engineers have designed the 3.4-liter V6 twin dual-cam engine so it is normally aspirated, with 4 valves per cylinder, 2 intake and 2 exhaust. Fuel is fed through the AC Rochester electronic injection system. This system eliminates the need for a cold start injector. The aluminum cylinder heads contain pressed-in valve guides and seat inserts. Both are precisely mated and machined in the manufacturing process for best performance. The valve guide inserts are made of a new composite that incorporates a dry lubricant in the material. Twin overhead camshaft carriers contain 1 intake and 1 exhaust camshaft each. The aluminum carrier itself serves as the camshaft bearing surface, eliminating the need for additional parts to service or wear down. The thrust plates mounted at the rear of the carriers maintain the camshaft location. The overhead camshafts are driven by a 2-phase system. An intermediate shaft driven by means of a chain from the crank, and a cog-toothed timing belt driven by the intermediate shaft and connected to the individual camshaft sprockets. Timing of the 3.4-liter V6 twin dual-cam engine is critical to optimum performance as well as customer drivability and satisfaction. Because pins or keys are not used to establish crankshaft to camshaft timing, the timing must be reset whenever the camshaft sprockets are removed. As long as the cam sprockets are not changed in reference to the camshafts, timing can be achieved by alignment of the factory timing reference marks placed in permanent ink on the belt sprockets. This will also align the torsional damper timing marks on the front cover. The 3.4-liter V6 twin dual-cam engine has a valve train engineered for maximum efficiency and minimum service. The valve train is direct acting, meaning the turning motion of the camshaft lobe is directly transferred to the hydraulic lifter. The lifter then acts directly against the valve tip, allowing the engine to operate more efficiently at a higher RPM. Because there are 4 valves per cylinder and the spark plug is located in the center of the cylinder, the 3.4-liter V6 twin dual-cam engine maintains precise fuel and airflow as well as optimum burn efficiency in the combustion chamber. The air intake is a 2-piece lightweight aluminum design. The lower manifold supports the 6 multi-port fuel injectors. The upper manifold is an integrated throttle body plenum assembly. The exhaust manifolds are high silicon moly cast nodular iron, each with a tuned 3-into-1 design. Lubrication of the 3.4-liter V6 twin dual-cam engine is achieved through a full-pressure, high-capacity gear-type oil pump. An oil cooler is designed into the system, using engine coolant to maintain low oil temperature. Oil is drawn up through the pickup screen and tube. Pressure is controlled by an oil pressure regulator valve inside the oil pump. Once passed through the filter, the oil is routed to the main oil gallery. The new and unique oil distribution cover diverts the oil supply to the left and right banks of the camshaft carriers. Longitudinal passages carry the oil to the hydraulic lifters and camshaft journals in each of the carriers. An anti-drainback valve has been designed into the oil distribution cover assembly. This valve retains a supply of oil in the overhead as well as in the passage below the valve after the engine is shut off, reducing cold start friction wear and engine startup noise. As you can see, a great deal of effort and engineering know-how has gone into the development of the 3.4-liter V6 twin dual-cam engine.
End Part 1. You should now prepare to take the first part of the test for this course. To take the test, you must have a number 2 pencil and the official student attendance and test form in front of you. Make sure the first 7 digits of the course number printed in Block 9 of the Student Attendance and Test Form match the first 7 digits of the course number printed on the back of the course book and the videotape label. If you do not have the correct materials, stop the video and get them. Begin by placing the Student Attendance and Test Form in front of you so that the clipped corner is in the lower right. In the upper left-hand corner of the form, you will see a series of circles below the letters A through E. At this time, you will be filling in the test answers only. At the end of this video, instructions for completing the remainder of the form will be provided. This is the only answer sheet you will need for this course. In a moment, you will see the first test question and several possible answers. When you have decided on your answer, completely fill in the circle below the letter corresponding to the correct answer. Since this test will be corrected by computer, it is important that you avoid making stray marks on the paper. If you change your mind about an answer, be sure to erase your first choice completely before marking the correct answer. It is also important to avoid getting dirt or grease on the answer sheet or folding it, as this may cause the computer to incorrectly score your test. As you take this test, remember that there is no time limit. You may take as much time as you wish to complete the test. You may also review the course book or rewind the videotape to find the correct answer. Begin Test Part 1 at line 1 of the test form. Test Part 1. Question number 1. The camshaft carrier, A, houses the camshafts. B, houses the lifters. C, serves as the camshaft bearing surfaces. D, is made of aluminum. Or E, all of the above. Question number 2. The overhead camshafts are driven by A, chains. B, a 2-phase system. C, gears. D, electricity, or E, oil pressure. Question number 3. The first phase of the two-phase timing system consists of A, the serpentine belt, B, the oil pump drive, C, the intermediate shaft driven by the crankshaft, D, the air compressor driving the camshafts, or E, the distributor system. Question number 4. The second phase of the two-phase timing system consists of A, the generator, B, the air pump, C, the oil pump driving the crankshaft, D, the intermediate shaft driving the timing belt and camshafts, or E, the serpentine belt driving the power steering pump.
Removal of the 3.4-liter V6 twin dual-cam engine is similar to that of the 3.1-liter. Like its predecessor, there are two different procedures which can be followed. An engine with a manual transaxle can only be removed by dropping the cradle and powertrain out the bottom of the vehicle. On vehicles with automatic transaxles, the engine can be hoisted out through the top or removed out the bottom of the vehicle. This vehicle is equipped with a 5-speed manual transaxle. The removal of the 3.4-liter V6 twin dual-cam engine from a vehicle equipped with an automatic transaxle will be detailed later in this video. Remove the air cleaner and the air duct assembly, then disconnect the battery cables and engine ground wires. From inside the vehicle, remove the under-dashboard sound insulator by unfastening the retaining screws. Caution! To prevent damage to the hydraulic clutch system, remove the master cylinder push rod from the clutch pedal. A screwdriver or pliers may be used to pop it free. Drain the cooling system and remove the coolant recovery tank. Hold your finger over the coolant recovery tank tube so as to prevent residual engine coolant from spilling. Remove the control cables at the throttle body of the plenum. Next, remove the serpentine drive belt. This is accomplished most easily by rotating the tensioner clockwise using a long-handled box-end wrench. Start by lifting the belt off the power steering pump pulley. Remove the plastic wiring harness cover and the two quick disconnect engine wiring connectors located near the right strut tower. Disconnect and pull out the fuel lines at the fuel rail. Depressurize the fuel system before you break the fuel lines. Unfasten the two bolts securing the engine torque strut and remove the strut. Also, slide off the engine coolant hoses. Unfasten the engine torque strut bracket at the upper tie bar. In order to remove the 3.4-liter V6 twin dual-cam powertrain, you'll need to take out the radiator supports and both engine cooling fan assemblies. It is not necessary to remove the radiator when removing the powertrain out the bottom of the vehicle. After disconnecting the electrical bulkhead connector at the right side of the cowl with a nut driver, remove the ECM and place the unit on top of the engine. In the same fashion, remove the convenient center wiring harness cover and the low coolant sensor electrical connectors and place the entire harness on top of the engine. If the vehicle is equipped with air conditioning, discharge the system using the ACR3 recovery unit to recover the refrigerant. Remove the lines at the compressor, using caution not to damage the fitting. To prevent damage, remove the shift control cable at the lever and the bracket. Remove the clutch actuator from the transaxle. Remove the heater hose pipe assembly to allow clearance for the master cylinder. Loosen and pull the upper strut retaining bolts. There are 3 on each side. You're now ready to raise the vehicle. Once elevated, pull both front wheel and tire assemblies. Taking out the exhaust catalytic converter assembly will help ease the removal of the 3.4 V6 powertrain. Next, remove the fastening bolts on both front brake caliper assemblies. do not disconnect the brake lines. Carefully support the entire brake caliper assemblies to the body. It is not necessary to disconnect the hydraulic lines or bleed the braking system to remove the 3.4-liter V6 twin dual cam engine. The engine, transaxle, and subframe assembly are now ready for removal. To ease removal of the engine from the manual transaxle, it will be necessary to remove various components from the powertrain. Start by removing the AC compressor. Next, remove the exhaust crossover pipe and engine mounting nuts and bolts. Remove the power steering lines and pump. Caution: care should be taken not to allow power steering fluid to leak into the front cover area. Fluid could leak into the belt cavity and weaken the belt. Remove the right drive axle from the transaxle. Remove the clutch fork from the throwout bearing like this. It is necessary to perform this step to prevent damage to the throwout bearing, which is part of the pressure plate assembly. Now, remove the engine and mount it on a stand. With the engine mounted on the stand, remove the EGR pipe at the manifold. Remove the throttle body, the map sensor, and the EGR electrical connectors.
End Part 2. You should now prepare to take the next part of the test for this course. If you are unsure of the answer, you may stop the tape to think about the question, review the course book, or rewind the tape and review it before answering. Test Part 2. Begin Test Part 2 at line 5 of the test form. Question number 5. To prevent damage to the clutch system, A. Unbolt transaxle mount bolts. B. Remove shift control cables. C. Disconnect parking brake system. D. Discharge air conditioning system. Or E. Disconnect the clutch master cylinder pushrod from the clutch pedal. Question number 6. To remove the powertrain on a vehicle equipped with a manual transaxle, there is no need to A. Use a vehicle hoist. B. Open the brake fluid lines. C. Remove the engine torque struts. D. Disconnect the battery connector. Or E. Drain engine coolant. Question number 7. To prevent damage to the pressure plate assembly when removing the engine from the transaxle, A. Remove the transaxle. B. Remove the air conditioner. C. Remove the engine. D. Remove the radiator. Or E. Remove the clutch fork from the throwout bearing.
As mentioned earlier, the procedure for removing the 3.4-liter V6 twin dual cam engine equipped with an automatic transaxle is slightly different from the procedure for one equipped with a manual transaxle. The engine can be removed by either hoisting it up or by lowering it out of the vehicle. This segment will outline the major differences in hoisting the engine rather than lowering the powertrain. Since there is no clutch system, there is no need to disconnect the clutch pushrod. However, you will need to disconnect the automatic transaxle cooler lines from the radiator and plug them to prevent leakage. Remove the radiator hoses and the electric fans from the radiator. Now, remove the radiator assembly. Remove the power steering lines. Caution: take care not to allow power steering fluid to leak onto the timing belt cover or the timing belt. Remove the exhaust crossover pipe to gain access to the transaxle bolts. Remove the 5 bolts connecting the transaxle to the engine, including the ground wires. Then remove the engine mount nuts and the torque converter to flex plate bolts. Using GM special tool number J35917, remove the right ball joint nut and separate it from the control arm. You can now remove the drive axle nut and washer and the drive axle assembly and shield. Remove the 4 engine mount bracket to transaxle bolts. lower the vehicle and install the engine lifting fixture. After removing the one remaining transaxle to engine bolt, the engine can be lifted from the vehicle and mounted on the stand.
End Part 3. You should now prepare to take the next part of the test for this course. If you are unsure of the answer, you may stop the tape to think about the question, review the course book, or rewind the tape and review it before answering. Test Part 3. Begin Test Part 3 at line 8 of the test form. Question number 8. The 3.4 V6 engine equipped with an automatic transaxle can be removed A. with quick disconnects, B. out the top of the vehicle, C. by removing the transaxle, D. out the bottom of the vehicle, or E. both B and D. Question number 9. When removing the 3.4 V6 engine equipped with an automatic transaxle out the top of the vehicle, you will need to A. remove the radiator, B. remove the power steering lines, C. remove the right drive axle, D. drain the coolant, or E. all of the above. Question number 10. When removing the 3.4 V6 engine equipped with an automatic transaxle, always A. disconnect and plug transaxle cooler lines, B. remove the input shaft, C. remove the oil pan, D. both A and C, or E. none of the above.
The EGR on the 3.4-liter V6 twin dual-cam engine is in two pieces with two single-piece gaskets. This maintains a positive seal and prevents any manifold leaks. A leak in the seal could cause improper vacuum pressure and affect drivability. The plenum is attached to the engine by 7 bolts and 2 nuts. After removing the bolts, disconnect the throttle body heater hose and lift the plenum assembly off of the engine. This will allow you to remove the spark plug wires at both banks and remove the spark plugs. Also, pull the necessary vacuum hoses. Check the label in the engine compartment for vacuum hose routing. The 2 upper timing belt covers can now be taken off of the engine by removing the 4 hold-down screws. There are 2 screws on each side at the front of the engine. Remove the serpentine drive belt tensioner assembly by removing the single mounting bolt. You're now ready to remove the molded plastic center timing belt cover, exposing the cog-toothed timing belt. Caution: the timing belt is designed to last a minimum of 70,000 miles, varying with driving conditions. It's important that you do not allow oil or dirt to come in contact with the timing belt or allow the belt to be cut, crimped, or twisted in any way, as this will affect expected performance and customer satisfaction. Remove the 4 bolts holding the cam carrier covers and remove the covers. The cam carrier covers are fitted with a molded silicone gasket with a fitted bead. Inspect the gasket for damage or signs of leakage. Next, align the painted-on timing belt sprocket marks. When servicing a timing belt, it is essential that the painted-on timing marks be aligned properly. If this critical step is not performed, the engine will not run properly. To align the painted-on timing marks, place a socket wrench on the crankshaft torsional damper bolt. Rotate the crankshaft clockwise. Align the machined torsional damper timing mark with the cast timing mark on the aluminum front cover. Make sure the camshaft sprocket painted-on timing marks are properly aligned, that is, facing one another like this. Also, make sure the intermediate shaft belt sprocket painted-on timing mark is aligned. This is TDC exhaust number 1 piston position. This timing procedure can be followed when the engine is still in the vehicle. There are additional procedures needed when timing the 3.4-liter V6 twin dual-cam engine after a complete engine reconditioning. If you're just replacing the timing belt, it is not necessary to remove the camshaft sprockets. To continue with a complete engine reconditioning, determine if the length of the belt is satisfactory. The bracket that the timing belt pulley mounts to has a cast notch to determine belt length. When the pulley moves into the timing belt to compensate for belt wear, the bottom edge of the pulley rotates closer to the cast notch in the bracket. The timing belt is in the acceptable range until a ruler can be inserted in the cast notch. The way to determine the length of the belt is to measure along the bottommost point of the tensioner pulley with a flat, narrow ruler. If the reading is 41.1 millimeters plus or minus 1.5 millimeters or 1.62 inches plus or minus 60 thousandths of an inch, the timing belt is in the acceptable range. A reading of 45.1 millimeters or 1.77 inches plus or minus 0.75 millimeters or 70 thousandths of an inch means the ruler is in the notch of the pulley bracket and the timing belt needs to be replaced. Another acceptable way to determine if there is excessive wear on the timing belt is to measure the length of the actuator from the center line of the pivot point, known as the trunnion, to the end of the rubber boot. For a new belt, if this measurement is between 80.5 millimeters or 3.2 inches and 89 millimeters or 3.5 inches, the belt is in the acceptable range. For a used belt, if the measurement is over 94 millimeters, which is 3.7 inches, the belt needs to be replaced. These measurements are to ensure proper belt tension. Some engines may be built with a special tensioner bracket. If the bracket is replaced or if decks are refaced, an optional length is available. Select the appropriate one. Once the acceptability of the belt is determined, loosely clamp the two cam sprockets on each side of the engine together using clamping pliers. This is to hold the engine in the timed position when replacing a timing belt. If the timing belt is to be reused, the direction of belt rotation should be marked on the edge of the belt for reassembly. Caution! It is important not to mar the cam sprockets with the clamping device. Make sure there is no deflection of the cam sprockets. If you see deflection or movement of the cam sprockets, loosen the clamping device. You can now remove the tensioner side plate retaining bolts from the tensioner and remove the side plate from the actuator base. Now, rotate the actuator assembly around the arm pivot and out of the mounting base. Removal of the tensioner from the base allows it to extend to its maximum travel length. Set the actuator on a table in the vertical position. Remove the rubber end plug and allow the oil to drain into the boot end. There is a tapered bushing between the actuator and the mounting base. Do not lose or damage the bushing when removing the tensioner assembly. In order to retract the tensioner, you'll need a standard smooth paper clip. Straighten the paper clip, leaving a small loop at one end. Holding the tensioner in one hand and the paper clip in the other, insert the paper clip into the center hole in the rubber vent plug and the small pilot hole. You do not need to remove the rubber plug. Now, insert a small screwdriver into the slot inside the small end of the tensioner. By turning the screw clockwise while pushing the rod tip against the tabletop, you'll be able to fully retract the tensioner plunger. Now, rotate the screw slot to align with the vent hole. Push the straight section of the paper clip into the screw slot to keep the plunger in the retracted position. Fill the tensioner with SAE 5W30 Mobile 1 oil or the equivalent if required. Fill to the bottom of the plug hole, then reinstall the end plug, making sure it is fully seated. Remove the timing belt pulley and arm assembly. Rotate the pulley forward to prevent the bushing from falling out. Remove the timing belt and place in a protective bag. Put in a protected area to prevent fluid penetration or damage. Next, remove the tensioner bracket and the cam sprockets. To remove the sprockets, you'll need special tool number J38616 and special tool number J38613. Caution: when installing the camshaft hold-down tool, make sure there is no oil remaining in the hold-down tool threaded hole. Oil in the hole can strip the hole or put the camshafts out of timing once the tool is locked down. The flats of the camshaft must be parallel within a tolerance of only plus or minus 5 degrees before installing clamps. If the flats are not parallel, the engine will not perform properly. The clamps will set final alignment when fully installed and torqued to specification. Place special tool number J38613, the camshaft hold-down tool, at the exposed opening on the flats of the camshafts. This locks the camshafts in place and will maintain the proper timing of the engine. Using special tool number J38616, pull the camshaft sprockets and the locking washers. Install the puller legs in the key slots of the sprocket like this, and then remove the sprocket by turning the thrust screw. At this point, inspect the nose of the camshaft for brinelling from the lock ring. Pressure marks are acceptable. However, grooves on the camshaft are not acceptable. A grooved camshaft must be replaced. Next, remove the generator and rear support bracket and the exhaust manifolds and accompanying heat shields. The manifold gaskets are reusable if not damaged. Disconnect the throttle body heater pipe and the engine torque strut bracket. You're now ready to remove the cam carrier. First, remove the 12 retaining bolts. It is important to work on only one side at a time. Before removing the cam carrier, rotate the engine assembly 120 degrees on the stand. This will keep the compensators, also known as lifters, from falling out. When removing the cam carriers in a vehicle, a vacuum hose positioned between the lifters will help to keep the lifters in place. The carrier can be removed without pulling the cam sprocket. But when performing a complete overhaul, it is easier to remove the sprocket with the carrier on the engine. The cam carrier can now be removed from the engine. It's a good idea at this point to remove the lifters from the cam carrier, since the cam carrier is already on the bench. Keep the lifters in order, checking first for excessive wear, scoring, or other damage. Now, remove the fuel rail retaining bolts, the fuel rail, and the attached wiring harness as a single unit. Remove the 12 intake manifold retaining bolts and lift the intake manifold off the engine. Remove the distributorless ignition system. Unfasten the torsional damper bolt. Then remove the 3 crankshaft pulley bolts and pulley. Now, remove the torsional damper using special tool J24420B. Now, remove the intermediate shaft belt sprocket bolt while keeping the crankshaft from rotating. The holes in the sprocket are not tapped, so the toolkit is supplied with 7/16 self-tapping bolts. Using special tool number J38616, remove the intermediate shaft belt drive sprocket. Rotate the engine on the stand and remove the oil pan and fitted gasket. When reinstalling, A small bead of sealer will be needed where the pan meets the lower flange of the front cover. You may notice that the coolant pump is located in the front cover. This allows for fewer parts, less weight, a direct drive, and efficient engine temperature maintenance. Remove the idler sprockets, the 10 front retaining bolts, the front cover, and the cover gasket. This gasket is not reusable. Next, remove the cylinder heads and gaskets. With the heads off the engine, check for any remaining gasket material and clean the surface of the heads. Do not use sharp metal scraping tools or any objects which may score the surface of the head. To improve lubrication, General Motors engineers have added a new, innovative oil distribution cover. It supplies the camshaft, lifters, and cam carrier with pressurized oil more efficiently. Remove the oil distribution cover. The gasket on the oil distribution cover is not reusable. Remove the oil filter, oil cooler, and oil level indicator tube, as well as the knock sensor and crankshaft position sensor. The oil pump driven unit is removed by loosening the bolt and lifting it out. This unit is another engineering innovation. It is located in what is normally the distributor hole. This mechanism is driven by the intermediate shaft and directly drives the oil pump. Now, remove the oil pump. Next, remove the oil baffle. A stamped steel baffle helps direct engine oil splash. By directing oil splash away from crankshaft rotation, it serves to reduce oil foaming. The new 3.4-liter V6 twin dual-cam engine uses a new timing chain assembly. It is included on the assembly of the partial block when shipped from manufacturing. The timing chain should require no maintenance or adjustments. The timing chain and both sprockets are removed as a single assembly. Mark the assembly with reference marks for reassembly. The crankshaft sprocket on the 3.4-liter twin dual-cam V6 is a press fit. With the tensioner bolts removed, special tool number J38611 is needed to remove the crankshaft sprocket. The intermediate shaft timing chain sprocket is mounted directly on the intermediate shaft and is not an interference fit. This is where the camshaft is located on the 3.1 V6 engine. Caution! It is not advisable to attempt to pry the intermediate shaft sprocket from the shaft. If the intermediate sprocket is difficult to remove, the intermediate shaft can be removed through the rear of the engine. This can be accomplished by removing the rear cover and the oil pump drive assembly. Tap the shaft out with a soft rubber or plastic mallet. Next, with the timing chain tensioner removed, retract the spring-loaded tensioner using special tool number J33875 and install the lock pin. The engine is now ready for an inspection of the components and reassembly.
End Part 4. You should now prepare to take the next part of the test for this course. If you are unsure of the answer, you may stop the tape to think about the question, review the course book, or rewind the tape and review it before answering. Test Part 4. Begin Test Part 4 at line 11 of the test form. Question number 11. To prevent damage to the belt, A. Do not allow oil or solutions to contact the timing belt. B. Do not bend, kink, or pry on the belt. C. Cut the belt. D. Soak the belt in alcohol. Or E. Both A and B. Question number 12. To bring the engine to the timed position, A. Align the painted-on timing belt sprocket marks. B. Align the camshaft with a crankshaft mark. C. Remove the torsional damper. D. Pull the alternator. Or E. Both C and D. Question number 13. The camshaft hold-down tool, A. Sets initial valve timing. B. Holds the camshafts in position. C. Is used when removing the camshaft sprockets. D. Is used to install the camshaft sprockets. Or E. All of the above. Question number 14. To remove the camshaft carrier in vehicle, you should A. Install vacuum hose between the lifters to hold them in place. B. Pull the coolant pump. C. Drain the engine oil. D. Remove the crankshaft sprocket. Or E. None of the above.
Before reassembly and reinstallation of the 3.4-liter V6 twin dual-cam engine, it's important to inspect all components for wear and replace or recondition those that are not up to General Motors design engineering standards. Beginning with the cylinder head, inspect the head gasket and mating surface for any signs of leaks or blow-by. If the gasket has failed, you need to determine the cause. Possible causes could include improper installation, a loose or warped cylinder head, improper torque on the cylinder head bolts, a marred or warped surface, or a cracked case. After checking for and determining the cause of any problem, clean the cylinder head. Do not use a motorized wire brush or any other tool that could damage the surface. Clean and inspect the cylinder head bolts for damaged threads, bolt heads, or any stretching. Any suspect bolts must be replaced. The cylinder head and manifold mating surfaces must be checked for flatness. The head deck must be flat within 0.1 millimeter or 4/1000ths of an inch. Caution: because the engine is a free spinning engine, the cylinder head can be machined no more than 0.010ths of an inch because of allowable piston-to-valve clearance. To remove the valves, use special tool J38606 to compress the springs and remove the valve locks, valve caps, valve springs, and stem seals. Now, slide out the valve. Do not remove the valve from the guide with a hammer or punch. With the valve removed, clean any carbon, varnish, or oil from the valve. Next, inspect the valve seats for excessive wear or burn spots. Valve seat guide clearance should not exceed 0.1 millimeter or 4/1000ths of an inch. Valve seats may be reconditioned by grinding. However, because of the valve lash limit in the hydraulic lifters, no more than 0.1500ths of an inch can be removed from the seat. Check valve tip height before and after conditioning. The valve face may be ground to specifications if it is otherwise in good condition. If not, it must be replaced. The tolerance limits on the valve face are 45 degrees face angle and 46 degrees seat angle. After grinding, measure the valve guide margin by inserting a valve into the corresponding valve guide. Push it 2 millimeters or 1/8 of an inch off the seat and move it from side to side. Measure the amount of movement with a dial indicator. It is also acceptable to use a hole gauge to measure the valve guide ID. Then measure the valve stem with a micrometer and compare the clearance. The acceptable clearance is 11/10,000ths of an inch to 26/10,000ths of an inch for the intake and 14/10,000ths to 31/10,000ths of an inch for the exhaust. If necessary, valve guides may be reamed to a maximum of 5/1000ths of an inch and oversized valves installed. Next, inspect the valve springs for wear. Springs with ends which are bent or not parallel must be replaced. When reassembling the cylinder head valve assembly, tape the valve lock groove to protect the new valve stem seal during installation. Intake and exhaust valve stem seals on the 3.4-liter V6 twin dual cam are the same. Using special tool J38606, compress and install the valve spring, the spring cap, and valve locks. If the valves and valve seats have been reconditioned, The valve spring height will need to be verified within tolerances. Next, inspect the camshaft lobes for excessive wear. If wear is found, the camshaft must be replaced. If a camshaft is replaced, you must replace the corresponding lifters. Make sure to completely remove the camshaft sprockets painted on timing marks, as they will not be used in reassembly and will have to be replaced after retiming the engine. Loosen the 6 fasteners on the rear of the cam carrier and remove the cam thrust plate cover and gasket. The camshaft is held in place by 2 fasteners and the thrust plate. Loosen the fasteners and remove the thrust plate. If the plate is worn, it must be replaced. Notice, it is essential that the camshafts be marked to identify which journal they belong in. Each of the 4 camshafts are different. To identify the difference, note the lobes on the intake camshaft are spaced farther apart. If camshafts are installed in the wrong carrier bank, you'll find the length of the camshaft compared to the length of the carrier is not correct. Now, check the cam carrier surface for flatness. If it is not true, it must be replaced. The cam carrier cannot be resurfaced. Next, replace the camshaft oil seal using special tool J38619. Use GM engine assembly pre-lube or its equivalent on the camshaft journals before reassembly. Avoid getting too much lubricant on the nose of the camshaft. When installing the camshaft, be careful not to scratch or nick the cam carrier. Reinstall the thrust plates, gasket, and cam carrier end cover. The thrust plates are installed from the top like this, and the cam carrier cover must be installed to match the lock plates. You can now insert the lifters, lubricating thoroughly with GM EOS or its equivalent. Next, reinstall the engine oil pump and baffle in the engine block. Next, slide in the oil pump drive unit. If possible, install the unit in its original position. Reattach the crankshaft position sensor and the knock sensor. Install the integrated engine oil cooler and the appropriate hose connectors leading to the engine coolant system, and install the engine oil filter. Install the oil distribution cover and gasket. You're now ready to rebuild the engine.
End Part 5. You should now prepare to take the next part of the test for this course. If you are unsure of the answer, you may stop the tape to think about the question, review the course book, or rewind the tape and review it before answering. Test Part 5. Begin Test Part 5 at line 15 of the test form. Question number 15. The cylinder head deck must be flat within A, 0.1 millimeter, or 4/1000ths of an inch. B, 1 inch or 25.4 millimeters. C, 6 inches across. D, 0 tolerance. Or E, 50/1000ths of an inch or 12.7 millimeters. Question number 16. The cylinder heads cannot be milled more than A, 10/1000ths of an inch. B, 100/1000ths of an inch. C, 250/1000ths of an inch. D, cannot be milled. Or E, 125/1000ths of an inch. Question number 17. Valve seats cannot be reconditioned more than A, 15/1000ths of an inch. B, 222/1000ths of an inch. C, 50/1000ths of an inch. D, 725/1000ths of an inch. Or E, cannot be reconditioned. Question number 18. It is critical to measure valve tip height after reconditioning because of A, the limited hydraulic valve lash in the lifters. B, heat transfer. C, proper lubrication. D, proper airflow. Or E, the aluminum heads.
First, install the new cylinder head gaskets. Lay the gasket flat with the metal tabs facing up. Mount the cylinder head and snug the head bolts. Many fastener torque procedures require the use of a torque angle meter. The torque angle specification is achieved by first tightening the fastener to the proper torque value, then continuing to turn the fastener to the desired angle, that is, the proper number of degrees after the torque threshold is achieved. First, tighten the head bolts in the proper sequence to 50 Newton meters or 37 foot-pounds. Then, tighten the bolts in sequence an additional 90 degrees using special tool number J36660. Improper torque angle on components can cause excessive oil consumption, scored bearings, a loose flywheel, broken connecting rods, or a broken crankshaft. Reference the torque angle meter operator's manual for instructions. Now, reinstall the oil indicator tube assembly. Tighten the fastener to 10 Newton meters or 89 inch-pounds. Install the timing chain and gear assembly in the original position. Properly seat the crankshaft and sprocket using special tool number J38612. Install the timing chain tensioner. Install the front cover gasket. Now lay a 1/8 inch bead of silicone along the flange of the front cover where it mates to the oil pan. Install the front cover so it is properly aligned with the dowel pins. Install the front cover bolts. Tighten the large front cover bolts to 47 Newton meters. Tighten the small front cover bolts to 25 Newton meters. Rotate the engine and install the oil pan gasket. Install the oil pan and torque the rail bolts to 10 Newton meters. Next, slide the torsional damper onto the shaft, placing a small amount of RTV in the keyway to prevent the possibility of an oil leak later. Using special tool J29113, seat the damper and install the pulley and the 3 pulley fastener bolts. Install the torsional damper bolt and tighten to 105 Newton meters. Reattach both engine mount brackets and the generator support bracket. Install the distributorless ignition system with the spark plug wires attached. Next, install the intermediate shaft timing belt sprocket on the shaft. Notice, make sure the intermediate shaft bolt is clean before installing or the proper torque will be unattainable. Do not forget to install the O-ring before installing the bolt. While holding the crankshaft in place, torque the retaining bolt to 130 Newton meters. Check to ensure the sprocket splines are fully engaged by measuring the distance between the front cover and the sprocket. It should be 42 millimeters or 1.65 inches from the front cover to the face of the sprocket. Next, install the timing belt tensioner bracket and 2 timing belt idler pulleys. The pulleys should move freely. Next, install the intake manifold gasket and intake manifold. To do this, use the vertical installation holes in the intake manifold to align the intake bolt grommet bores with the threaded holes in the cylinder heads. This will minimize the possibility of cross-threading or damaging the grommets, which would create a manifold gasket leak. Install the mounting bolts and rubber isolators fully into the manifold flange before you tighten any fasteners. Now tighten the bolts to 25 Newton meters or 18 foot-pounds. Draw the manifold into place by tightening the bolts gradually, starting with the middle bolts and working out in a circular pattern like this. To install the cam carrier to head gasket and the cam carrier, first rotate the engine 120 degrees to prevent the lifters from falling out. Now, with the stand in its original position, torque the retaining bolts to 25 Newton meters. It's important that you only work on one cylinder bank at a time. When installing the cam carrier in vehicle, use petroleum jelly to help hold the lifters in place. Also, use the recommended vacuum hoses to hold them in place. Be sure the noise seals are positioned between the carriers and the front cover. Next, install the vacuum line harness along with the fuel rail and wiring harness. Make sure the injectors are properly seated in the manifold before tightening the fasteners. Torque the fuel rail fasteners to 10 Newton meters. With both camshaft hold-down tools properly installed, it is now possible to mount the camshaft sprockets. Insert the new shim rings in the counterbore of the sprockets. Seat the rings against the raised inner lip. Lightly lubricate the nose of the camshaft with engine oil and slide on the sprockets. The sprockets should spin freely at this point. Next, install the lock ring washers on the nose of the camshaft, engaging the flat land at the edge of the rib into the gap between the flat ring and the camshaft nose. Lightly oil the camshaft sprocket bolt threads and washer before installing. Now, thread a bolt and washer into the camshaft and seat the bolt finger tight. Back off that bolt 1/2 turn. Repeat the procedure for the remaining camshaft sprockets. Install the timing belt starting at the intermediate cam belt sprocket and working counterclockwise. Slide the belt on, rotating it around the idler pulleys and sprockets. Do not bend or kink the belt or try to pry the belt into place. Make sure the belt is installed in the direction of rotation and that the old painted-on timing marks on the camshaft sprockets have been removed. Accumulate the belt slack at the tensioner in this fashion. Now, mount the tensioner pulley to the mounting base. Use a flat magnet or tape to hold the pivot tube in the pulley during this step, or the pivot tube may fall out. Caution! Make sure the tensioner pivot is at 9 o'clock when installing the pulley, or damage to the pulley may result. Tighten the bolt to 50 Newton meters or 37 foot-pounds. Make sure the pulley rotates freely like this. It is very important that the arm bushing and pivot be clean and free of oil. Do not lubricate the arm bushing or pivot. Put the side plate on the actuator. Now, install the actuator assembly, engaging the tapered trunnion on the rear of the tensioner in the mounting bracket. Make sure the assembly rotates freely under its own weight after the side plate is torqued to specifications. Engage the actuator ball into the socket by gently rotating the tensioner pulley 15 Newton meters or 12 foot-pounds counterclockwise into the belt, using the square lug in the arm. Now, pull the paper clip out of the actuator, allowing the pulley to move onto the belt. Caution! Be careful not to damage the tensioner boot. Now set the final pulley tension at 16 to 20 Newton meters or 12 to 15 foot-pounds of torque. Rotate the engine clockwise, that is, the direction of the engine rotation, 3 times to seat the belt. Do not reverse engine rotation. Check the timing marks on the front cover and torsional damper to make certain they are properly aligned. To obtain the maximum timing accuracy, hold the cam sprockets in place using special tool number J38614. While keeping the crankshaft from turning, seat the lock ring on the right camshaft sprockets, starting with the right exhaust and right intake camshafts. Now, tighten each sprocket bolt on this cylinder bank. The running torque before seating the bolt should be 60 to 90 Newton meters or 44 to 66 foot-pounds. Notice, if less torque is required, the shim ring and the lock ring must be replaced, and the nose of the camshaft inspected. If more torque is required, inspect the bolt threads for burrs or other foreign objects. The lock ring is properly seated when the edge is flush with the sprocket hub. At that point, tighten the bolt to 110 Newton meters or 81 foot-pounds. Remove the special hold-down tool on the right-hand side and rotate the engine clockwise 1 revolution, or any odd number of revolutions, realigning the machined timing marks on the torsional damper and the front cover so they are at top dead center piston position. Again, do not reverse the rotation of the engine. Hold the crankshaft in position. Repeat the same procedure on the left cylinder bank. Now, remove the left carrier hold-down tool. After completing that procedure, rotate the engine one more time and realign the machined timing marks on the torsional damper and front cover. Number 1 cylinder is now at top dead center exhaust again. You may now add the new painted-on timing marks. They must be applied parallel with the camshaft sprocket bolts where the 2 sprockets mesh. This is for your convenience should you ever need to retime the engine without removing the sprockets at some future date. The intermediate shaft belt sprocket painted marks should be at 6 o'clock, which is straight down. With the engine now properly timed, you can install the front engine lift hook, the engine torque strut bracket, the throttle body heater pipe and bracket. Install the 2 exhaust manifold gaskets and the 2 manifolds, tightening the remaining bolts to 13 Newton meters. Now, install the generator and rear support bracket. Before installing the 2 camshaft carrier covers, first inspect the cover gasket for any signs of wear. The gasket is molded rubber and is fitted into a machined groove on the cover. Now, realign and fasten in place the molded plastic center timing belt cover. When installing the serpentine drive belt tensioner, make sure the raised lock fitting is aligned with the machined slot in the front cover. The tensioner assembly can only be installed if the lock fittings are properly mated. You can now bolt both upper timing belt covers in place. Now, reinstall the spark plugs and plug wires on both cylinder banks. Bolt on the plenum, checking to make certain the gasket is properly fitted. Then reinstall the throttle body heater hose. Next, install the vacuum lines near the map sensor, the fuel rail pipe bracket, the throttle body, map sensor, EGR electrical connectors, and the EGR pipe at the exhaust manifold. Now, refill the crankcase with oil. Remove the engine from the stand and reinstall the engine assembly to the transaxle and frame assembly. Then reinstall the transaxle to engine mounting bolts and torque them to specifications. Reattach the clutch fork to the throwout bearing assembly. The power steering pump, lines, and brackets can now be reattached. Caution! Take special care not to allow power steering fluid to leak onto the engine. After bolting on the engine mounts and brackets, install the engine mount bracket to the 4 transaxle bolts. After installing the axle shield, attach the right drive axle to the transaxle, making sure it is properly seated. You're now ready to install the exhaust crossover pipe, air conditioning compressor, and the electrical connectors to the wiring harness at the rear of the engine. Install the powertrain. After reinstalling the powertrain in the vehicle, make certain all the engine coolant hoses are connected and all the electrical and vacuum connections have been properly made. When starting the new 3.4-liter V6 twin dual-cam engine for the first time after rebuilding, run the engine until normal operating temperature is achieved. Drive the vehicle at part throttle with moderate acceleration until normal operating conditions return. Also, check all vehicle systems for proper operation before delivering the vehicle to the customer. Make certain all systems are working properly.
End Part 6. Before answering the last video test questions, please complete the portion of the student attendance and test form that identifies you and your dealership. If this portion of the answer sheet is not completed correctly, you and your dealership will not receive credit or certification for this course. Begin by placing the student attendance and test form in front of you so that the clipped corner is now in the upper right. Print your last name in block 1, located in the upper left-hand corner, putting only one letter in each box. Print your first and middle initials in block 2. Print the name of your dealership in block 3. Your dealership city in block 4. And state in block 5. Be sure to use the official U.S. Postal Service abbreviation for your dealership state. Print your Social Security number in block 6. Do not fill in the block marked dealer code. Print today's date in block 8. Return to block 1 in the upper left-hand corner of the form. Below each letter of your name is an alphabet. Fill in the circle with a letter that corresponds to the letter of your name at the top of the column. Follow the same procedure for the numbers of your Social Security number in block 6. And today's date in block 8. Remember that the course book accompanying this videotape contains the final part of the test. Test Part 6. Begin Test Part 6 at line 19 of the test form. Question number 19. The cylinder head bolts should be fastened, A, starting from the middle and working clockwise out to the end. B, to 50 Newton meters plus 90 degrees. C, to 25 Newton meters. D, to 100 Newton meters. Or E, both A and B. Question number 20. After you install the intermediate shaft belt sprocket, A, install the camshaft. B, install the crankshaft. C, install the engine. D, check to make sure it is fully engaged with the intermediate shaft. Or E, both A and B. Question number 21. When installing the camshaft sprockets, you must A, install lock rings and lock washers. B, engage lock ring washer flatland between the camshaft nose and flat ring. C, install the sprocket and bolt so it spins freely. D, use the camshaft hold-down tool. Or E, all of the above. Question number 22. During the timing procedure, it is important to A, ensure the tensioner pulley and tensioner rotate freely. B, align the timing mark on the torsional damper with the front cover timing mark accurately. C, ensure that the tension on the belt is properly achieved. D, time one bank at a time. Or E, all of the above. Question number 23. When timing the engine, it is important A, that the camshaft sprockets reach the required torque properly. B, to properly seat the timing belt. C, to tighten all the camshaft sprockets at the same time. D, both A and B. Or E, none of the above. You have now completed the video portion of the test. The course book accompanying this videotape contains the final part of the test. Once you have completed the test, you may wish to make a photocopy of it for your records. After photocopying, place the original student attendance and test form in the pre-addressed envelope. No postage is needed. Remember to complete the questions in the back of the course book before mailing the test form to CPT headquarters. Good luck.